Okay, so welcome to the review of exponent properties and scientific notation. So we're going to get straight into this. We're going to start off and do the first four examples. Actually, the first 6 examples without the use of the TI Inspire, and then we'll use the TI Inspire for the examples that relate to scientific notation. Okay, so what we're going to do is a quick review and reminder of the properties of exponents, particularly those when we're multiplying, when we're dividing, when we're raising exponents, or rather when we're raising parentheses to an exponent, when we have negative exponents, and when we have 0 exponents. And so those are effectively the 5 rules, and I'm going to talk through them as we go through the examples. So as you can see in example 1, what we have here is a multiplication, and so the rule is write down the base and add the exponents, and of course you can only add the exponents of any base which is the same. So in this case 2 and 3 are both bases, but since they're in number form, if you like, we simply say 2 times 3, which is going to give us 6, and I'm going to cross those out as I go. Not necessary to do this, but just so I can keep track. And then the next thing I'm going to do is write down my base. I have an x squared and an x to the 3. I'm adding powers, that gives me x to the 5. I have a y to the 3 and a y with no exponent, which means 1. So I write down the base, add the exponents, 3 plus 1, y to the 4, and at that point I'm done. Okay, we're going to move into example number 2. What we have here is a combination problem where we are multiplying and dividing. And so basically we can do this all in one go. What we need to remember is when multiplying, write down the base, add the powers. When dividing, we subtract the powers. The power on the numerator minus the power in the denominator. So what I'm going to do is just begin by putting in a couple, or actually 3 ones, because we have 3 bases without exponents, so those are each 1. Then what I'm going to do is write down my bases. I have x as a base, I have y as a base, and I have z or z as a base. And so I'm going to add or subtract depending on whether we are multiplying or dividing. So I have 5 plus 1 minus 1, and that's for the x to the power of 1 in the denominator. So 5 plus the 1 for the term on top, minus the 1 for the term on the bottom. And then I'll just change colors over here. For y, we have a y squared, a y to the 7, and a y to the 3. And so we're going to say y to the 2 plus 7 minus 3. And lastly, for the z, we only have a z to the power of 1 in the numerator. So I'm just going to leave that as is. And now I'm just going to add and subtract my not my like terms, I beg your pardon, my exponents. So I have x to the power of 5, y to the power of 6, z to the power of 1. Okay, moving on to the next question. Here again we have a combination question. We have multiplication, but we also have parentheses raised to an exponent. So 2 important things. First of all, we must deal with the parentheses first, according to the rule of PEDMAS or PEMDAS or BODMAS, whichever version you learnt. And so we will deal with this term first, and then we can deal with our multiplication. Okay, and so what I'm going to do is say that's x to the power of 8, y to the power of 2, and I'm going to leave that exactly as is, and I'm going to come over here and focus on what's inside the parentheses. So same rule as before, y has no exponent, so I'm going to put a 1 in there. Just make that a little bit clearer, y to the power of 1. The rule when raising parentheses to a power is write down the base and multiply the powers. And so in this case I'm going to write down my bases, y on the top, x on the bottom, and I'm going to multiply each of their powers. 4 times 1 is going to give me 4, and 4 times 2 is going to give me 8 for the exponent in the denominator. Okay, and then what you can hopefully see here is we have multiplication and division. We can simply extend the division line, and then the problem looks very much like example 2. And so I'm going to proceed in the same way. I'm going to write down my 2 bases, which are x and y, and I'm going to subtract the exponents. So for the x's I have 8 minus 8 because it's division. In the case of the y's, they're both in the numerator, and so that is multiplication. And so I have y to the 2 times y to the 4, which is y to the 2 plus 4. That leaves me with x to the 0, y to the 6. And this is an opportune time to remind you of the other rule, which says anything to the power of 0 is in fact 1. And so you could just write your final answer as y to the power of 6 or 1y to the power of 6. Those are the same thing. Okay, moving on to example 4. Now we have the most complicated of all of them because there are multiple rules combined. We have parentheses raised to an exponent. The exponent is negative and we have a 0 power. So we're going to start off, and quite easily I can essentially ignore that because that's multiplying by 1 and that leaves everything the same. The next thing I'm going to do is deal with the parentheses according to the order of operations. And so for each of those, I'm going to write down the bases, and I'm going to multiply the exponents because I have parentheses raised by a power. And then what I'm going to do is leave the y to the minus 1, this term over here, by itself, and I'm dealing essentially with the terms from the parentheses first. Okay, so we have x to the power of 2 multiplied by minus 3 leaves you with minus 6. Y to the power of minus 1 times minus 3 becomes positive 3. And we now have the following expression. This is a multiplication. And so I'm going to start off by leaving the x alone. There are no other x's. Y, since I'm multiplying, I'm going to write down the base, add the powers. 3 plus minus 1 is going to leave me with 2. And the last piece that we need to take care of is the rule that says you are not allowed to leave any negative exponents in your answer. And you'll see that's in the instruction as well. You must write your answer with only positive exponents. And the final rule to remember is anytime we have a base with a negative exponent, it moves, in this case, from the numerator to the denominator, but the reverse rule can also be true. And so in this case, we move x to the minus 6 to the denominator, and it becomes x to the positive 6. Okay, so moving along now, we've got the last 4 problems. This is scientific notation. A couple of quick reminders with scientific notation. This term at the front must be between 1 and 10, and then we write times 10 to the power of. A negative implies a decimal, and then if it's positive, of course, we're talking about a larger number. So the first 2 are going to be done without the calculator. We've got a number in scientific notation. You've been asked to write it in standard form. And then question 6 is the opposite problem. It's in standard notation and we're being asked for scientific. Okay, and so basically this is a reminder of how to move the decimal place. And so this is telling you to move the decimal place 4 places to the left. Okay, and so in standard form, if I were to move this 4 places, 1, 2, 3, 4 places to the left, imagine that 5's not there. I'm going to get the number 0. And so we have the decimal point's going to go here. I'm going to have a 0 there, 0, 0, 0, and then we have our 2. So 0.0000275, and that is the same as 2.75 times 10 to the power of minus 4. The next example is the reverse. So this time I'm given a very large number. And what I need to do is write that in scientific notation. So I have my decimal place here. I need to count how many spaces to move until I'm going to get to 6.79, because that is a number between 1 and 10. And so let's count that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. And so we write our number as 6.79 multiplied by 10 to the power of 9, because that's how many decimal places we had to move it. Okay, and then the last 2 examples really are extensions of these that involve multiplying, squaring, dividing, and what we're going to do for these is use the TI Inspire. And so let me pull my calculator up. Remember, you can take care of these, the easiest way is to put the calculator into scientific notation mode, particularly if you want your answers, as is the case here, in scientific notation. So that's what I'm going to do. Let me remind you how to do that. I'm going to go to the home screen. I'm interested in settings, document settings, and what I want to do is go to the third one there where it says exponential format. I want to select scientific, and then I want to make that the default. And then I'm going to go back into my, well, actually what I'm going to do is I'm going to create a new document, and I'm going to put a calculator, select calculator, and I'm going to go ahead and type these in. Okay, the other reminder, of course, is this double E button is the one that gives you exponents. And so what I have now is a set of parentheses. I have 7.5 e, which is multiplied by 10 to the power of 4. So 7.5 e4 is the same thing as 7.5 times 10 to the power of 4. You could, if you wish, use the 10 to the x button, but there's no need. So it's 7.5 e4, and I'm going outside the parentheses. I want to raise that to the power of 2, so I'm just going to push the squared button, hit enter, and there we have our answer given in scientific notation, 5.625 e9, or 5.625 times 10 to the power of 9. I'm going to go ahead and calculate do the second one as well. Again, with division, we must remember to use our parentheses, so 2.03 e7, and then I'm going to go outside my parentheses, divided by, open a second set of parentheses, 8.14 e negative 3, and once again, the calculator will do the calculation for you and leave your answer in scientific notation if that's the mode that you're in. And so let me just slide that over so I can see the two answers that I'm interested in, and I'll just transfer those over here. And so the answer here, 5.625 times 10 to the power of 9. You must not write E9, that's calculator notation, and so you must use the appropriate scientific notation. And then my second answer, 2.493, and probably 4939 if I round off. That'll be enough, because remember the idea is to write this as an estimate. So I'm going to just do that, 2.4939 times 10 to the power of 9. Okay, and so that is your review of exponent properties as well as scientific notation, both by hand and on the calculator. And what you need to do now is turn your attention to the practice worksheet.